Hi everyone, now that we've learned all of our exponent rules, we're going to work on problems where we have to use multiple rules in the same problem. And the nice thing here is that you'll have some choice in how you approach the problem. So a lot of times there's going to be more than one way to do it. They'll all get you to the same answer, but you might find that your brain processes these problems slightly different than someone else. So for these examples in the video, we're going to do each problem two different ways. There may be more, but I just want to show you different ways that you might want to think about the problems. So let's go ahead and start with the first problem. So I'm going to recopy it here. I have 2x cubed to the fifth times 4x squared to the 0 power. Now for this, what you might notice is that this base here is raised to the 0 power, and we know that anything to the 0 power is just 1. So the nice thing here is that now really all I have to deal with is my 2x cubed to the fifth power, because that times 1 is just going to leave us with the 2x cubed to the fifth power. Now hopefully we'll realize here, we know this 2 has a power of 1, and so we can distribute that exponent, the 5, to both the 1 and to the 3. Now our bases don't change, so I'm going to have 2. Let's see, 1 times 5 is going to give me to the fifth power. My base here is going to stay in x, but now I have 5 times 3 is going to give me to the 15th power. So now what we can do is in our calculator, we can actually evaluate 2 to the fifth power. Hopefully we're getting good with doing exponents now. We're going to do 2, use this caret key here, type in 5, and then when I hit enter I get 2 to the fifth is 32. And then I have x to the 15th power. And that's as simple as we can make it. Now, let's think about how we might do this another way. I'm going to take the same problem and let's say I just decided I wanted to get rid of all of the parentheses first. So looking here, I know the 2 has a power of 1, the 4 has an exponent of 1, so I can go ahead and distribute or multiply these exponents. So I'm going to do that for both factors here. So when I do that, again, I'm going to still have a base of 2. My exponent is going to be 5 times 1, which is 5. I'm multiplying that by my base of x to the power of 15. Now I'm still multiplying here. This is all multiplied together. So now my base is 4. 0 times 1 just gives me an exponent of 0. And for my last factor here, my base is x, and 2 times 0 gives me 0. So now all my parentheses are gone, so it might be a little easier to deal with. Now, hopefully we recognize we've got 4 to the 0, which is 1, and x to the 0, which is 1. So we're left with 2 to the fifth times x to the 15th power times 1 times 1. So again, I can go back to my calculator. I have 2 to the fifth power is going to give me 32. X to the 15th I can't simplify anymore, and multiplying by 1 is just going to give me that same answer. So no matter which way I did it, I got the same answer. Again, it's just kind of a little dependent on how your brain sees things and how you see the order of these problems. So let's go on to the next one. Alright, so I have the quantity 2x cubed, and I'm raising that to the second power. Then I'm multiplying by x to the fourth. Now let's say I don't remember that I can distribute these exponents, but I do know that I could take 2x cubed. If I'm squaring 2x cubed, it means I'm taking this and I'm going to multiply it by itself 2 times. So I could do 2x cubed times 2x cubed and then I can multiply that by x to the fourth. So now I see that I have these coefficients. I've got a 2 and another 2. So if I multiply those, I'm going to get 2 times 2 is 4. I also see that I have this base of x here. So I know I'm going to have a power with a base of x. And I also know when I'm multiplying powers, I can add the exponents. So 3 plus 3 is 6 plus 4 is going to give me an exponent of 10. So here we used our idea of expanding this out, and then we knew we were multiplying powers, so we added our exponent. Those were our rules. Another way I might look at this is I might say, well, if I look at this, I know I'm taking this power and raising it to an exponent. And that to me means that I can distribute or multiply these exponents. We've used that rule several times now. So my base of 2 here is going to have an exponent of 2 times 1, which is 2. My base of x is going to have an exponent of 2 times 3, which is 6. And then I'm still going to multiply by this x to the fourth. So now I can use my calculator, or just in my head, I know 2 squared is 2 times 2, which is 4. I see that I have this base of x, so I'm going to keep my x, and I know when I'm multiplying powers with the same base, I'm going to add the exponents. So 6 plus 4 is going to give me 10. So again, the exact way you go after it doesn't matter as long as you're following the rules, but you do have options, and either of these are valid options. All right, let's just do one more, and then we'll save the last one for class. All right, this one's kind of a big problem here, so let's see what we've got. I'm going to recopy it. 2s over 3t to the third power times t to the fifth over 16. So let's see, I'm going to go ahead and think about distributing these exponents. So 2 has a power of 1, and 3 has a power of 1, and t also has a power of 1. So I need to multiply, I guess here, I also have s. All my exponents happen to be 1. So when I multiply that out, I'm going to get 2. Well, let's see, my exponent is 3 times 1, so I have to the third power, times s. Again, when I multiply it, it's 3 times 1, which is 3. All over, now I can't forget to multiply in the bottom. I have a base of 3, but 3 times 1 is 3. And the same thing with my base of t. My power is 1. I'm going to multiply it by 3, so I get an exponent of 3. And now there's really nothing I can do here, so I'm just going to write times t to the fifth over 16. Now, the nice thing about multiplying by fractions is all we need to do is multiply the top times the top. So on top, I can just simplify this. I'm going to make it one big fraction. I have 2 cubed times s cubed times t to the fifth. And on the bottom, I'm going to do the same thing. Just multiply the bottom times the bottom. So I have 3 cubed times t cubed times 16. So now is the time where we're going to do some simplifying. And so I'm going to deal with these coefficients first. I know 2 cubed on top, let's see, I'm going to get, if we're not sure, we know 2 times 2 is 4 times 2 is 8, or we could use our calculator. On the bottom, I actually have 3 cubed times 16. So I'm going to use my calculator to help me do all of that. So I'm going to type in 3 to the third power, which we call 3 cubed, times 16, and I get 432 in the denominator. Now let's see. I only have an s on top, so that's just going to stay here as s cubed. When I look at t to the fifth, now I'm dividing powers, t to the fifth on top and t to the third on the bottom. So I'm going to subtract those exponents, and 5 minus 3 will give me 2. Now, I'm noticing that these are both evens, my 8 and my 432. So the last thing I'm going to do is use my calculator to help me reduce that fraction. So again, to enter a fraction, I'm going to do my alpha y equals. I'm going to hit enter. On top, I'm going to put 8, and on the bottom, I'm going to put 432. And my calculator is going to give me the reduced fraction. So now on top, I have 1. On the bottom, I have 54. And I'm still going to have my s cubed and t squared. And that's my final answer. Now, obviously, we could write this without the 1 on the top. We could just leave it s cubed t squared over 54, but having the 1 there, I would accept that as well. All right, let's think about how else we might do this, especially if maybe distributing these exponents, if you're worried you're going to miss one. Let's see how else we could do this. So if I have 2s over 3t, and that's cubed, times t to the fifth over 16. I'm going to deal with this piece first. I know the fact that this is to the third power means I can do 2s over 3t times 2s over 3t times 2s over 3t. So I multiplied this by itself 3 times, and then I still have to multiply by t to the fifth over 16. Now again, when we're multiplying, we know we're going to multiply everything in the numerator together to get our new numerator. So that means I'm going to multiply, let's take our coefficients. 2 times 2 is 4, times 2 is 8. My base is going to stay s. Now here we have to be careful. When we're multiplying powers with the same base, we know we add the exponents. Well, these each have an exponent of 1, so if I add 1 plus 1 plus 1, I'm going to get s cubed. And then I still have t to the fifth. Now on the bottom, I'm going to do the same thing. Let's see, what color do I have here? I'm going to multiply all my my denominators together. So I'm going to multiply 3 times 3 times 3 times 16. And again, I would just use my calculator to do that. 3 times 3 times 16 is going to give me that 432. My base each time is a t. And again, because each of these exponents is really a 1, when I add them together, I get t cubed. So I'm going to use my calculator again. We know we could simplify 8 over 432, right? That gave us 1 over 54. My s cubed here is still going to stay. And then we would deal with our t cubed t to the fifth power over t cubed is going to give us t, and we subtract the exponent, so it's going to be t squared. So again, either way, our answer is exactly the same. The process of getting there was just a little bit different. All right, so that's plenty for this video. We'll go over the last example in class together and talk about how we might come up with multiple ways of simplifying, and then you'll have lots of time to practice so we make sure we're really good at all of these rules. All right, thanks, and I'll see you in class.